Good morning, gentlemen. This is Sachdeva on this side. I will speak on the 3D printing in substation roll-off, while my colleague Mr. Soda will speak on the usage of 3D printer in Vizag substation or power grid. As far as 3D printing in India is concerned, it has made a big stride, and most of the R&D institutions and universities, as well as the industry, as well as the manufacturers, they have making all out their efforts to bring the sources for 3D printing taking in the country. And the civil people have particularly this L&T construction has done already the two-story building, while uh, Indian Army has already taken up 3D printer used in the construction of Jawan's houses, then sentry posts, roads, and other things. Development of 3D printing is based on the mission which we are following, Atmanirbhar and carbon neutrality. The the institution which has taken up use of 3D printing is PowerGrid, who is using the 3D printer in making the components which have been normal wear and tear in HV Vizag substation, Vizag converter station, and Mr. Soda will speak on this. The National Center for Additive Manufacturing, Osmania University, Hyderabad, has set up the research center. Similarly, VIT Chennai and said that is advanced material has Bombay has set up the center in college. Then IIT Ropar has installed ESM 290 metal 3D printer. Then IIT Guwahati in giant development with Delta E in forming Belgium for 3D concrete printing and using construction waste material. Then the Tata Technology, which has set up a consultancy center for helping the new institutions or new user how to use the 3D printing. And then India for Sustainable 3D Printing Experience Center by WL3D. These are some of these, and others are coming up. Manufacturing in India has taken a big number. 55 total are available at present. Delhi 5, Gujarat 4, Karnataka 6, Kerala 1, MP 1, Maharashtra 17, Rajasthan 1, and Tamil Nadu 14, Telangana 3, UP 2. Now, type of 3D printers, though in industry there are about 7 type of conventional, one is the new one. Each has about 2 to 3 type of printers. So that mean about 20, 30 printers type of printers are available. But generally, which are in common use is 3 type. One is stereolithographic apparatus, which is called SLA printer, equipped with a laser that forms liquid resin into plastic. The second one is selective laser sintering SL splitters, equipped with a laser that sinters particles by a polymer powder into an already solid structure. Then fused deposition modeling FDM printer, most commonly release thermoplastic filament melted through a hot nozzle form on this. In the below picture shows the 3D printer and their operating flow, which is already what has been spoken there above. These are the first type is SLA, other second type is SLS, and third type is FDM. The diagrams are self-explanatory. Now, with the before the other software which are in addition to printers are required, slicing software and slicer, which is slicer is a slicing program. Slicers transform a digital model into a set of instruction that 3D printer transform uh, uh, into produce a tangible part, and slicers show user to define key parameters is print orientation, layer height, support structure, print speeds, infill densities, continuous fiber reinforcement, and other things. Cura 3D is the most known slicer available. 3D printing simulation software. These are the softwares which are used to simulate, test, and perform factors, and 3D printing simulation software runs this simulation to determine if the part passes or fail the virtual performance test. Next is 3D printing inspection software. When the part begins printing, the software automates the collection, upload, and registration requirement data through onboard laser, micrometer, and a scanning process to help user ascertain if each part printed is within the acceptable. Ultimately, the automated inspection of parts boosts manufacturing productivity by producing manpower and their use. This is the 3D exploded view of the printer, and which on the left side you will find this step studer, which is shows the plastic filament going down. This is FDM system, and at the end you find a hat end which will melt the metal core that into the plastic. The core is wrapped in insulation. Then next one is drive motor, which on the top of body of the this thing, which give you three direction: x-axis, y-axis, z-axis. Generally, the printers are with two axes, x-axis and y-axis, and 3Ds in a special industrial printers. Power grid has only two axes, x-axis, y-axis, but that two x-axis it goes in one direction, then it changes direction into y-axis. So it's not simultaneously acting x and y direction. Then at the bottom you get the you see the extruder controller and then the motherboard, which controls the uh, process of depositing as well as give the commands. Then stepper motor is there, which control the speeds, translate commands from the motherboard into the higher current pulses to replay or move the. Then again we come back to nozzle. So now we move to the next. Then this shows the components of the 3D printer in a simple form, which these components are of the printer which is available with the. The first one is extruder, filament feeding mechanism, then printer head, then printer bed, then stepper motor, then the motherboard, which gives the all the instruction and other thing how to do. The 3D printer process is below shown. What is the printing? The first is the 3D, and the data is fed by ID into CAD printer. Then it goes to material section, which material to be selected. Then it go to slicer. Then it go to 3 printing machine. There is decided which type of printing is there: SLD, SLA, LS, or PDF, PDM, and then goes to the post processing, and then goes to final product. Here it shows the picture of the various. This is shows the printer which is at IIT Roorkee, and the other one is which is coming for the Hyderabad, and next one shown on the left side is the right side is the printer which is available at Vizag. In the below you will see the SLA printer and SLS printer and PDM printer which is commonly used. 3D printing or additive manufacturing available in India is power grid, which I have already told, and Mr. Soda will speak more. Its volume is 30 centimeters, and it was purchased in 2018-19. Indian Army has used it for building Jawan quarters, houses, 3D printed sentry posts, and all these things which I have already spoken. Power utilities adopt three principal works: control room, the auxiliary power supply, roads and other structures similar to that which is L&T and Indian Army is doing. So they can also follow the civil practices, and they can take the guidance from the institution which are uh, carrying out R&D, like your uh, IIT, and other places. CA purchased 3D CAD with associated software for optimizing space requirement substation and designing lighting protection use 3D ruling sphere method. CA has standing committee which goes into the failure of investigation by having meetings with the various uh, suppliers and manufacturers and users. But it is proposed that they shall also make use of 3D printing for investigation failure. Substation existing, if they want to be extended further, terrestrial radar with 3D scanner can scan the existing substation and decide about extension. Terrestrial radar scanning can provide a comprehensive survey for all the equipment, structure, foundation, buswork, and lines and in the substation. In a few hours, couple of technicians can take a laser snapshot of the substation without being exposed to any dangerous clearance issue normally associated with the energized substation work, and also vital substation and engineering computer. In the international, as I have already said, that Russia, Ural Federal University of Russia, they have done, they have put a printing setup, which is being used for the training of the students as well as the staff. They have already uh, made models for the CT, 110 kV CT, 220 kV CT, and also scan the transformers and lower part of the transformer, which is shown in the pictures to be followed. Siemens and Ribose, in a strategic partnership, pull together, skill the create complete workflow for the installation of 3D printing and increase the production opportunity of companies involved in the energy, mobility, and aerospace. And, April 22, Siemens opened the Charlotte Advanced Technology Collaboration Hub called CAT in North Carolina. Schneider also deployed 3D printer status FDM supplied by local distributor. Excel system is one of the technology enabling Schneider to transition a small factory, the smart factory. The factory has become a workhorse, turning out assembly line tools, jigs, fixtures, robot grippers, and other and functions. Also deployed sharpened 3D printer using Pro 10 resin from the Raspberry Chinese deployed for manufacturing of air circuit breakers. You see, normally the components which are mentioned in the first para, they are generally used in the factory itself for handling the equipment. They get wear and tear. So instead of ordering into outside, they themselves manufacture and take lesser time and the continuity in the working of this thing. In other utilities like PGE California has successfully implemented ventilator substation for the 3D new substation, as also create the model of the existing substation and then uh, add new bay or new extension, whatever is required. So they are using 3D ventilator of this thing, and other uh, sources are Descartes, ventilator substation, context capture, macro station, project wise. Duke and NPL, PNL are some of more utilities who are doing making use of 3D printing. Then this shows the university, rural university, the prints taken of the current transformer, 110 kV, then the kit for the CT, 110 kV CT and 220 kV CT, which helps the student to assemble and disassemble the CT. Then this is the model of the 110 kV CT, and this is the dismantle parts of the 110 kV CT, which has been formed with the laser. And next one is the shows the lower portion of the transformer, which giving various parts of the transformer, and then this is the scaled of 110 kV and 220 kV CTs. Then This is the main substation layout and components of the substation layout, and this is the transformer, which is 110 by 33 kV transformer, which is under investigation. Scan photo of that one. So then we come to the conclusion wherein whatever I have repeated is same thing put there, saying this thing that center, R&D institutes, state center, R&D institutes, and industry has done made a lot of strides 3D printing, and there are six number of universities and business complexes and about 55 manufacturers in the country. PowerGrid used 3D printer from 2018-19 in their HVDC converter substation at Vizag. And this will be explained, has been explained by Mr. Soda. Indian Army has done a lot of work on this thing. The Union Territory, Ladakh, now they have taken exploring the use of 3D printing technology in construction of buildings and repair of mechanical equipment. Being on high altitude, lesser manpower available, and stresses are much more manpower. Working hours are small. So as such, 3D printing is definitely going to. She has standing committee for investigation and this thing. They shall also make use of 3D printing to investigate the failure reason. Satellite data with 3D scanner can be existing sufficient and decide about extension. Power utilities adopt 3D printing and civil works and L&T construction and this thing. Bidders are now supplying 3D drawings for substation equipment and power utility or the private sector shall make use of the 3D model, 3D printer software and supply side 3D simulation and inspection software. Yeah, the power utilities and the contractors shall be encouraged to adopt the 3D hardware for speedy and quality work as also make contribution to net zero conversion. Thank you very much. And we follow by adopting the 3D printing one will be the Prime Minister Atam Bharat Mission and achieve the carbon neutrality. Thank you very much.